All right, we've got 2 molecules of nitrous oxide react with 3 molecules of oxygen, and that's going to produce 4 molecules of nitrogen dioxide. And they tell us we've got 0.055 moles of oxygen, and the N2O, we have 0.01 moles of that. And this is all in a 500 milliliter flask. So unlike previous problems, all the previous problems we looked at, they gave us concentration already. Here, they didn't give us concentration. They gave us moles and volume. So right now I know moles of oxygen, moles of nitrous oxide. To find concentration, molarity, right? That's moles per liter. So I have a 0.5 liter volume. So I'm going to divide both of these by 0.5 to turn both of them into a concentration. And that's going to make my concentration of oxygen, my concentration of the nitrous oxide. Yeah, 0.11 molar oxygen, and then 0.02 molar nitrous oxide. And then they also tell us the equilibrium concentration of nitrogen dioxide was 0.01 molar, right? What is the value of Kc for this reaction? So we know our initial concentrations. So N2O, oxygen, NO2, my initial, my change, my equilibrium. Right, our initial concentration, 0 for that. For the nitrous, 0.02 molar, for the oxygen, 0.11 molar. Our change, if we go and look at our coefficients, right? If we look at our coefficients here, basically say, yeah, we could call them all X, I think would be easy enough to say, just to make it easy on ourselves, right? This would be minus 2x, minus 3x, and that's going to be plus 4x. Plus 4x, well, they tell us that the final concentration is 0.1 molar nitrogen, 0.01 molar nitrogen dioxide. So that's how much I must have added in. I must have added in 0.01 molar nitrogen dioxide. So what is X? Well, that change, right? 4x is that 0.01 molar. Divide both sides by 4, and X is 0.0025. Right, would be our change in X. Now we're just going to go back through and plug that in for the change for X in the other change brackets. So if we take a look, right, 2x would be 0.005, and then 3x would be 0.0075. So we subtract. All right, I'm going to get 0.015 there, and then 0.11 minus 0.0075. And I get 0.1025 there. This concentration right here, the 0.01, they told us that in the question. It says in the second to last sentence, the equilibrium concentration of nitrogen dioxide is 0.01 molar. At least in my version of the question, that's what they tell us the equilibrium concentration was. So I use the fact that I know the initial is 0, the equilibrium is 0.01 to find that the change must be, right, the change must be 0.01 as well, because I started at 0 and I ended at 0.01. So yeah, this value right here came from the question. Now that we know what X is, now that we know the equilibrium concentrations, we can find the equilibrium constant for this reaction. Right? Equilibrium constant would equal concentration nitrogen dioxide to the 4th all over nitrous oxide concentration squared times my concentration of oxygen cubed. I want to plug in, right there, plug in my equilibrium concentrations. So 0.01 to the fourth all over 0.015 squared times 0.1025 cubed. Put that all together. And we're going to divide that by 0.015 squared times 0.1025 cubed. And I get an equilibrium constant for this reaction of about 4.1 times 10 to the minus 2. So 0.041 for the equilibrium constant for this reaction. Sure, I got 4x equals 0.01 because in the question, they told us my initial concentration of these three. And then they said at equilibrium, I have this much nitrogen dioxide. Well, we know at the start of the reaction, we have 0 nitrogen dioxide because that's our product. We haven't formed any product yet at the start of the reaction. Once it reaches equilibrium, I have 0.01 molar of that. So the change must also be 0.01 molar. And when I look at the balanced equation, right, the balanced equation says for every 2 of these, I need 3 oxygen, and I'm going to make 4 nitrogen dioxide. So, all right, setting this up in terms of X, that means for every 2x of the nitrous oxide that reacts, 3x oxygen also needs to react. And again, based on stoichiometry, all right, based on stoichiometry, that's going to make 4x of the nitrogen dioxide. So, okay, I started at 0, I ended at 0.01. The change is 4x. So whatever 4x is, it must equal the 0.01 molar. And then I divide by 4 to find out what is x. Correct. So Sarah asks, that would only be if our initial concentration is 0. Correct. If our initial concentration is 0, our change equals our equilibrium concentration. If we had an initial concentration of nitrogen dioxide, we'd have to subtract the 2, right, to find the change, to find what exactly is the change between my initial and my final concentration.